Hello everyone, I am Shivani and welcome to Civil Series. This video series is going to be a very interesting because it consists of PYQs from the all exams. So stay tuned and watch complete video. As you all know, many of the civil engineering exams are conducted day by day. And for all these exams, two things are very important. First is the syllabus and second are the previous year questions. So here I come along with a video series of previous year questions. So this video is regarding the previous year questions from WRD CEA exam. Okay, so first we discuss what the pattern of WRD CEA exam. This WRD exam consists of two categories. First is technical section and second is non-technical section. Technical section consists of civil engineering related questions. These are 40 questions for 80 marks and non-technical section consists of 60 questions for 120 marks. Non-technical section consists of four different parts. First is Marathi for 30 marks, second English for 30 marks, third, aptitude reasoning for 30 marks, and last is GK GS for remaining 30 marks. So, so in this session, we see 10 questions from the WRD exam. From the 10 questions, 2 questions are from building, material and construction, 2 questions are from irrigation engineering, and remaining 1 questions from strength of material, centrifugal pump, estimation, costing and valuation, pre-stressed concrete, construction planning and management, and highway engineering. For all these subjects, there is only one question. So let's see the first question is from building material and construction. So question is, in the context of timber, which kind of defect is shown in given figure? This is given figure and these are the options. In the given figure, one thing is observing that cracks are formed from outer side to inner side of this timber. Okay, let's first discuss the parts of timber. The central part of this timber is pith, and after pith there is heartwood, then after heartwood there is sapwood, then after sapwood there is cambium layer, after cambium layer there is inner bark, and after inner bark there is outer bark, which is the outermost layer of timber. Okay, and these all layers are considered as a annular rings, and there are medullary rings which are perpendicular to the all annular rings. Okay, so here in this figure, one thing is observing that the cracks at the outermost part are broader than the innermost part. So the cracks are forming from outer part, means from bark towards the sapwood. Therefore, these types of defects are called as star shakes. So these are the star shakes. Star shakes are the cracks propagating from near the edge of the log towards the center. Okay, so in this question, only discussing the answer is not enough. Okay, so for overall study or complete conceptual clearance, you need to see other options from the question. So first we see the heart shake, knots and cup shake before moving to the second question. Here, these are the figures related to the defects in a timber. First is a cup shake, which is partial split up of timber due to the shrinkage of timber or uneven growth of timber. Similarly, ring shakes. Ring shake is a complete split up of timber due to uneven growth or due to shrinkage of timber. Okay, then next is heart shakes. Heart shakes are opposite to the star shake. In case of star shakes, the cracks are formed from outer part to inner part, but in case of heart shakes, the cracks are formed from inner side to outer side. Then next is knot. Knot is a defect formed in a timber due to cut off or die off of branch from the timber or a tree. Then this is the theoretical part related to heart shake, knot and cup shake. You can go through this. Then second question is from strength of material. Question is the deflection at the center of simply supported beam length L. Okay, beam length is L, carrying a point load W at the center. Okay, here the simply supported beam is given and the length is L with a point load W at its center. Here the condition is given and they ask deflection related to this condition. Okay, these are the options given. Here this is the simply supported beam. Then the length is L with point load W at its center. Okay, to find out the deflection of any beam, first we know the bending moment and slope related to that beam. Then the maximum bending moment for this simply supported beam with length L and point load W at its center is WL by 4. If you haven't any clue related to maximum bending moment or shear force, then you can check a mechanics playlist from my channel, or else I will put the link in description or in comment section. Then next, with the help of maximum bending moment, you can find the slope. Okay, the slope is ml by 4 ei. Okay, these are the different formulas for the slope and deflection. I will provide you a chart of different conditions of beams and loadings. For that different conditions of beam and loading, there are different slope and deflections. You can go through that chart for all the different conditions. So for this beam, the slope is ml by 4 ei. Okay, here just replace the m with maximum bending moment, so the slope is wl square divided by 16 ei. Then next is deflection. Deflection is slope into L by 3. Therefore, the deflection for this beam is WL cube divided by 48 EI. Option number first is the correct answer. Then next, this is the chart for the different conditions of beam with different loadings. First is the cantilever beam with movement at its end. Then second is cantilever beam with point load at its end. Third is the cantilever beam with UDL. Fourth is a cantilever beam with uniformly distributed load. Third is the simply supported beam with point load. Fourth is a simply supported beam with uniformly distributed load. These are the maximum bending moment for this different kind of beams. These are the slope and these are the deflections. Then next third question is from the building material and construction. Question is, which of the following is not the property of plaster of Paris? Okay, plaster of Paris is the building material. So here three properties are given, and in that three properties they ask us that which is not the property of plaster of Paris. So first, specific gravity is 1.2. Not correct. Specific gravity of plaster of Paris is 2.57. Okay, I repeat again, specific gravity of plaster of Paris is 2.57. Then next point, black in color. No, plaster of Paris is white in color. Okay, so first is wrong, second is wrong. Then third, setting time is 5 to 10 minutes. Yes, this is correct. Then from the option, first and second is wrong. So here they ask not the property. So the option is only 1 and 2. So these are some extra points related to plaster of Paris properties. So plaster of Paris is non-inflammable, non-combustible. It has a very low chemical reactivity, and in extreme condition it acts as an oxidizing agent. Plaster of Paris has a high fire resistance, and this material is ideal to heat insulation. The next fourth question is from the centrifugal pump. Question is, in the context of centrifugal pump efficiency, which of the following is a correct equation of manometric efficiency? Okay, so here they just asked the formula of manometric efficiency. So from the options. First, weight of water lifted divided by 1000. No, this is not the formula. Then second, manometric head into head imparted by impeller to water. No, if this multiplication is replaced with division, then this option is correct. Okay, but because of this multiplication, this option is wrong. Then next, power at the impeller to power at the shaft. No, this is not a manometric efficiency. This is the mechanical efficiency. Power at the shaft, power at the impeller to power at the shaft is the mechanical efficiency. Then next, manometric head to head imparted by impeller to water. Yes, this is the correct option. The manometric efficiency is manometric head to head imparted by impeller to water. Then this is the formula for mechanical efficiency, which is power at the impeller to power at the shaft. Then overall efficiency is the product of manometric efficiency and mechanical efficiency. Then next, fifth question is from estimation, costing and valuation. This is question related to the unit of measurement. Okay, here the question is given. Here on the left side the items are given, and on the right side the unit of measurements are given. First is railing, second is centering and shuttering, third is gusset plate. Okay, so railing is measured in meter, centering and shuttering. Centering and shuttering are the formwork related parts or formwork related terms which are measured in square meter or meter square, and then gusset plate which are used to joint or which are used to form a joint. Okay, and these are measured in quintal. So these are the correct options for the unit of measurement. Railing is measured in meter, centering and shuttering is measured in square meter, gusset plate is measured in quintal. Then these are the some particular atoms and with their unit of measurement. You can go through this table and this is very useful. Then next, sixth question is from pre-stressed concrete. Okay, question number 6. Dash is a method of pre-stressing in which tendons are placed inside ducts or passages provided in concrete after concrete gain a sufficient strength. Okay, so here focus on this after. Okay, here pre-stressing in which tendons are placed inside the ducts or passages. Tendons are placed inside the duct or passages provided in concrete after concrete gains sufficient strength. Okay, after means post. Okay, so here the answer should be post tensioning. Okay, so from this option, the option number first is correct here. Then pre-tensioning means before. Okay, steel wires are tensioned before concrete is placed and hardened. Then anchorage is also called as fastening, and these fastenings or anchorage are used to connect the structural and non-structural components to a concrete structure. Then full pre-stressing that this is the level of pressing in which no tensile stress is allowed in a concrete under service load. Okay, then next question is from construction planning and management. Question number 7. Question is, in the context of measuring of safety injury index. Okay, in the context of measuring of safety injury index expressed by which of the following equation? Here the question is same. Here they just ask the formula of injury index. Okay, so in the first three options the numerator is same but the denominator is changed. So for injury index the denominator is always 1000 and the numerator is injury frequency rate into injury into severity rate. Okay, so this is the formula for injury index. The correct answer is option number 2. Then next question is from irrigation engineering. Question number 8. Which of the following statement is correct regarding lining of irrigation channels? Okay, so here they ask a correct option regarding the irrigation channel. So first is lining of canal prevent and reduces the weed growth. Yes, it prevent and reduce the weed growth. Also, it prevent the seepage and reduces the seepage loss. Okay, then first option is correct. Then second, earth type lining is a type of canal lining. Yes, and also a hard surface lining. Okay, earth type lining or second is hard surface lining. These two are the types of canal lining. So both options are correct. So answer is both first and second. Option number 3 is correct. Then canal lining. Canal lining is some kind of lining which is used to waterlog or to prevent the seepage of water or to prevent the percolation of water from ground reservoir. Okay. Then next question is from irrigation engineering. Question number 9. Question is dash consists of undressed stone block set in mortar and laid over a prepared subgrade. Okay, so these are the options and the answer is stone block lining. Okay, so stone block lining is laid with the cement mortar or lime mortar for the canal lining, and that stone block lining is also the undressed stone block set in a mortar and which is laid over a prepared subgrade. So the correct answer is stone block lining. Then we'll see the other options. So clay puddle lining, which is a traditional material for a lining of canals and which is other waterways, which is used for the other waterways and as well as for repairing the leaks in earthen dams. Then soil cement lining. That soil cement lining, it consists of a cement which is very minimum, which is 2 to 8% by the volume of soil. Okay, in the soil cement lining, two ingredients are there, only soil and cement. Soil is in very large quantity, and by 2 to 8% of soil quantity, there is cement. Okay, within a definite proportion, and this is used to line the canal. Then next is asphaltic lining. Asphaltic lining is the combination of cement and sand with hot condition, and this is also used to line the canals and the irrigation system. And the last question from this session is from the highway engineering. The question is the basic principle in CBR test is by causing a cylindrical plunger of dash diameter to penetrate into the specimen of soil. Here these are the options, and here they just ask the diameter of penetrator, and the diameter for the CBR test is 50 mm. Option number 3 is correct. CBR test is a California bearing ratio test, and that test is used to find out the stability of soil, and in that test two penetrations are done. First for 2.5 mm for the standard loading of 1370 kg, and second for 5 mm for standard loading of 2055 kg respectively. I think up till now you cleared all the questions, all the 10 questions with detailed explanation. So now the question arises, what about the remaining questions? So don't worry, remaining question video will be coming soon within a 2 to 3 days. So for that you need to subscribe the channel and hit the bell icon so you get a notification of the posted video. And okay, thank you for watching.